Hi, in this video, we are going to do some revision for algebra for JEE. Now, the topic that I want to discuss today is binomial theorem. The contents of this video is useful for students who have already studied the chapter and are trying to revise it for their exams that are coming up. So this is a revision video. The theory videos are already there on the channel, and you should look at them for more detail. However, we'll cover every result that is important, and then in the next few videos, we'll do some problems on this topic. And similarly for other topics in algebra as well. So let's begin. What is binomial theorem? So basically, it's a way to expand an expression of the form x plus a power n. And we can say that this expansion is nc0 x power n plus nc1 x power n minus 1a plus nc2 x power n minus 2a square, and so on till ncn a power n. Now this can be written in a summation notation. To quickly write it and save some space, you can write it like this: summation r goes from 0 to n. The general term is ncr x power n minus r a power r, right? So this is my general summation notation with which we can write binomial theorem. And obviously here the NC0, NC1, and so on till NCN are the binomial coefficients, right? Now, in case the expansion is not x plus a power n, and if it is x minus a power n, what will we do? So you should notice that every time a appears an odd number of times, the terms will become negative. So this will be negative, the fourth term will be negative, and so on. So the general expression in that case becomes r goes from 0 to n minus 1 power r ncr x power n minus r and a power r. So this is my expansion for binomial theorem where it is x minus a power n, right? And now some generalizations of this for the common cases that you might see. 1 plus x power n, what is that? So that will be r goes from 0 to n. This is ncr and 1 to the power n minus r and x to the power r. So it is simply this. And similarly, 1 minus x power n will become summation r goes from 0 to n, ncr minus 1 power r and x power r, right? So that is your normal binomial theorem expansion. Now, obviously, you should know the number of terms in the expansion of x plus a power n. The number of terms are n plus 1, because you should realize that r goes from 0 to n. So when you write this ncr x power n minus r a power r is going from 0 to n, and so there should be n plus 1 terms there, right? There is standard theory about which is the middle term and so on, but that is pretty obvious because it is n plus 1 terms. If n is odd, then n plus 1 is even, right? So there will be two middle terms in that case, which are the n plus 1 by 2th term and the n plus 3 by 2th term. That is the case when n is odd and the number of terms is even. And if n is even, then the number of terms n plus 1 is odd. And in that case, there will be only one middle term, which will be the term n by 2 plus 1. This term is the middle term. So when you do the expansion, you will be able to easily realize what is the middle term. So that should not come as a surprise to anyone. The general term of any binomial theorem is written like this. This is the general term. This is the term r plus 1, right? So you will use that in problems several times when you need a general term to basically think about how to solve the problem. For example, there could be a question like this. Find the coefficient of x power k in the expansion of let's say a x power p plus b by x power q whole to the power n. So we want to find the coefficient of x power k in this expansion. So first we'll write the general term tr plus 1 will be equal to ncr a x power p to the power n minus r multiplied by b by x power q whole to the power r. So this becomes what? ncr a power n minus r b power r x power np minus rp minus rq, right? So now this term should have a power of k. So therefore, np minus rp minus rq should be equal to k. So you're getting np minus k is equal to r times p plus q. So therefore, r is equal to np minus k by p plus q. And once we get this value of r, we will put that in this expression. So our coefficient will be NCR a power n minus r times b power r, where r is equal to np minus k by p plus q. So this is the type of problem that you will solve if you know how to write the general term of the binomial expansion. So you should be aware of that. Now, how do we generalize the binomial expansion? So there is something called the multinomial expansion as well. Multinomial expansion, where it is not a binomial expression of two terms, it could be a multinomial expression with more than two variables. So for example, here there are m variables and we want to raise it to the power n, right? So how do we do the expansion of this? So the general formula is simple. It is summation of terms like n factorial by n1 factorial, n2 factorial till nm factorial. And these n, n1, n2, nm are all integers. And it is x1 power n1, x2 power n2, and similarly xm power nm. So basically think about it. Each term x1, x2, x3 till xm has been raised to the powers n1, n2, nm. And the coefficient of that is going to be n factorial by n1, n2, nm factorial, right? So you have to think of it as if you are multiplying this thing n times and you are trying to get x1 n1 times, right? So there are n1 x1s that you have to choose, n2 x2s, n3 x3s in such a way that n1 plus n2 plus nm should add up to n, right? So this is the condition on these integers n1, n2, nm. They should add up to the overall coefficient. And this is your coefficient of the term x1 power n1, x2 power n2, and so on, xm power nm, right? Now, how many terms are there in this series? The number of terms in the multinomial expansion, the general case, is equal to n plus m minus 1 c m minus 1. So you need to remember this. This is my expansion. This is how you expand it. There are going to be many terms here, and the number of terms will be n plus m minus 1 c m minus 1. So for example, if you had a series like this, x plus y plus z to the power n, right? So notice here the m is equal to 3. There are 3 terms. It's a trinomial. The number of terms in this series would be n plus 3 minus 1. So n plus 2 c2. There are n plus 2 c2 terms here. Okay, fine. Now we look at some of the standard results that you might have encountered in the chapter once you use binomial and multinomial expansions. So let's look at these. So the first result that I want to talk about is the fact that 1 plus alpha to the power n minus 1 this will be divisible by, is divisible by alpha. Why are we saying that? It is divisible by alpha because when you expand it, it will be 1 plus nc1 alpha plus nc2 alpha square and so on. But when you subtract minus 1 from it, this minus 1 gets cancelled here, and you can see that every term that remains has alpha common at least, right? So similarly, you can also say things like this: 1 plus alpha power n minus n alpha minus 1 is divisible by alpha square. And similarly, 1 plus alpha power n minus nc2 alpha square minus n alpha minus 1 is divisible by alpha cube. These types of things come in really handy when you're doing divisibility problems based on binomial theorem. So the reason we are getting for all of this is simply expand it, and you'll be able to cancel the square terms here, the linear terms and the constant term, and you'll be left with nc3 alpha 3 plus nc4 alpha power 4 and higher terms. So obviously that you can see that alpha cube can be taken common here, and it is divisible by alpha cube, right? Now, some more standard results that you should know are results like these. So what is the coefficient of x to the power n minus 1 in the expansion? In the expansion, x minus alpha 1, x minus alpha 2, x minus alpha n, right? So think about it. This is like there are so many linear factors, there are n linear factors. So obviously it should be a polynomial of degree n. Polynomial of degree n. So also notice that the factor, the coefficient of x in each of these factors is 1. So if somebody asked me coefficient of x power n in this polynomial, the answer would be simply 1. However, we need the coefficient of x power n minus 1. So that means we have to select n minus 1 x's and one constant, right? When we are building up the term which is x power n minus 1, out of each of these brackets, we have to select x n minus 1 times, and we have to select one constant one time, right? So for example, if I select constant minus alpha 1 and I select x's throughout, I will get a term like this: minus alpha 1 x power n minus 1. However, there are so many ways to select the constant. There will also be a term minus alpha 2 x power n minus 1, minus alpha 3 x power n minus 1, right? And all of these terms will be added, and you should realize that the coefficient of x power n minus 1 here will be minus of alpha 1 plus alpha 2 till alpha n. So this is a statement that I have made that is pretty obvious here, how we get the coefficient of x power n minus 1 in this product, right? Another related result will be coefficient of x power n minus 1 in the expansion of x plus alpha 1, x plus alpha 2, and so on till x plus alpha n. And the coefficient would be simply alpha 1 plus alpha 2 plus alpha n. This is the required coefficient, right? Now let's do a slightly less obvious part. Coefficient of x power n minus 2 in the same expansion, x minus alpha 1, x minus alpha 2 till x minus alpha n, right? So now basically you have to select two constants, and you have to then add up the remaining terms will be x, right? So there will be terms like this: alpha 1, alpha 2, x power n minus 2, alpha 2, alpha 3, x power n minus 2, and so on. So technically you're looking for summation of alpha 1, alpha 2 alpha 1, alpha 3, and terms like this, right? So the way to do that is simple. This is summation of terms taken two at a time. So the coefficient would be summation, not summation. The coefficient will be simply alpha 1 plus alpha 2 till alpha n whole square minus alpha 1 square plus alpha 2 square till alpha n square. This is from the perfect square, we are subtracting the sum of squares. So that is going to be 2 times product sum of the terms taken two at a time, and this divided by 2. This is equal to summation of alpha beta, right? So this is the required coefficient of x bar n minus 2 here. Think about it. These terms will appear if you do whole square minus the sum of squares divided by 2, right? Okay. Now we are going to look at some standard results on binomial coefficients. So if x plus a bar n is my binomial series, it was written as C0 x bar n plus C1 x bar n minus 1 plus C2 x bar n minus 2 and so on till Cn x bar 0 a bar n, right? This was a square, by the way, and this was a, right? So this was my series. Now, if I use the expansion 1 plus x bar n, the series will be even simpler. It will be C0 plus C1x plus C2x square and C3x cube till Cn x bar n. Now, using this series, we can come up with a lot of results on binomial coefficients. The first result is C0 plus C1 plus C2 plus Cn is equal to 2 power n. That comes by simply putting x is equal to 1 in this sequence, in this expansion. Then there is C0 minus C1 plus C2 minus C3 and so on, plus minus 1 power n C power n is 0. If you put x is equal to minus 1 here, you will get that. So then from 1 and 2, if you add it, you will realize that C0 plus C2 plus C4 is same as C1 plus C3 plus C5, and both of them are equal to 2 power n minus 1. So add and subtract these 1 and 2 results and you will end up with this. Okay. The next thing is basically the result here. What is C1 plus 2C2 plus 3C3 and so on till NCN. And that is equal to summation. This can be written as summation of R goes from 1 to N, R times NCR, right? And that is basically N into 2 power N minus 1. So this is also a standard result. The way we get it is we directly differentiate this expression. If you differentiate this expression and then put x is equal to 1, you will get C1 plus 2, C2 plus 3, C3 and so on till NCN. And that will be n times 1 plus x power n minus 1. And when you put x is equal to 1, you end up with n times 2 power n minus 1, right? Okay. The fifth result is basically C1 minus 2C2 plus 3C3 and minus the alternating signs. So that will be equal to 0 because when it was C1 plus 2C2, it was N1 plus x power n minus 1, right? This was summation of R NCR where R goes from 1 to N. This was what we got as the summation after differentiating. So here if we put here, this would have been x power 1 C1 x power r minus 1, right? So if you put x is equal to minus 1 here, what you will end up with is C1 minus 2C2 plus 3C3 minus and all alternating signs. And this side will be simply 0 because x is equal to minus 1 makes this term 0, right? Okay. Then we have the next result, which is result 6. And this says MC0 times NCR plus NC1 times NCR minus 1 and so on till NCR and NC0. This is equal to M plus NCR. Now, how do we get this? Basically, you will write 1 plus x power m normal series mc0 plus mc1x plus mc2x square and so on till mcm x power m. And then you will write x plus 1 power n. So that will give you nc0 plus nc1 x power n minus 1 plus nc2 x power n minus 2 and so on till ncn, and this was x power n, right? We are taking these two series, we are multiplying and find the coefficient of x power r in the combined series in the product. So take one series as the normal series and take the other series as a reverse series x plus 1 power n and find the coefficient of x power r. So x power r will come when you do x power n minus r here. So ncr and mc0 mcr. So ncr and mc0 if you take, you will get, it is actually coefficient of x power n minus r that we can take, right? nc0 times ncr is becoming coefficient of x power n minus r. So basically, another way to think about it, this is what we needed, right? So ncr minus 1 and so on till mcr nc0. So another way to do it would be to do 1 plus x power n and x plus 1 power m. So this would give us a term like ncr x power r, and this would give us a term like mc0 x power n m plus mc1 x power m minus 1 and so on till mcm x power 0. So by the way, all of these binomial coefficients can be interchanged. So mc0 is same as mc0 x power m. We can rewrite the series in this way also, mcm x power 0 plus mcm minus 1 x power 1 and so on. And mcm can be replaced with mc0 and this can be replaced with mc1 x power 1, mc2 x square and so on. And now you multiply the two series, mc0 times this is going to give you coefficient of x power r. The first term would be this term multiplied by this term. The second term would be ncr minus 1 x power r minus 1 multiplied by this term, right? So ncr minus 1 multiplied by mc1. Finally, the product of the two series is 1 plus x power m plus n, and the coefficient of x power r there is m plus ncr. So the answer of this summation is simply m plus ncr. So you should know this result. This is a common enough example and it is there in all standard textbooks. You should be aware of it. The next one is basically generalization of the previous one. So C0 CR plus C1 CR plus 1 plus Cn minus R Cn is going to be 2n Cn minus R. So again, here the gap between the terms is R. Every time the gap is R, right? And again, this can be done by product of two different series. So try to think of the proof for this one. It's standard result, which is present in most textbooks. The generalization of this result would be C0 square plus C1 square plus C2 square and so on till Cn square. And here R is equal to 0, so it is 2n Cn, right? Then there are results based on integrating. So for example, the standard result is C0 plus C1 by 2x plus C2 by 3x square plus Cn by n plus 1 x power n is equal to 1 plus x power n plus 1 minus 1 by n plus 1 times x. So basically here x can be taken here and you get C0x plus C1 x square by 2 plus C2 x cube by 3 till Cn by n plus 1 x bar n plus 1, and that is basically 1 plus x bar n plus 1 minus 1 by n plus 1. And this result has come by integrating the standard binomial theorem from doing an indefinite integral on both sides, and you will end up with this. And then you can put limits of 0 to 1 on both sides. If you put limits of 0 to 1, you will end up with results like this. C0 by 1 plus C1 by 2 plus C2 by 3 till Cn by n plus 1 is going to be 2 power n plus 1 minus 1 by n plus 1, right? So if you change the limits, you can get similar results. For example, you can get a result like C0 by 1 minus C1 by 2 plus C2 by 3 minus. So there are alternating signs here, and it goes on till minus 1 power n Cn by n plus 1. And this was under the limits 0 to minus 1 or minus 1 to 0, and this will become 1 by n plus 1. So you should try out these, and these come out as simple answers based on what you have integrated and what are the limits you have chosen, right? Okay. Then there are situations like if you have fx, which is any polynomial function, which is equal to some multinomial raised to some power. So basically you can say, let's say a1x plus a2y plus a3z whole to the power n is equal to f of x, right? Or you could have taken different variables also. XYZ is given here. So technically this will be a function of XYZ. Now, in that case, if you wanted to find the sum of the coefficients of all the terms in the expansion, all you have to do is put all the variables as 1. X plus y plus z is equal to 1. If you put all the variables as 1, the terms will just have simply coefficients, right? So you will end up with something like a1 plus a2 plus a3, or basically f of 1. a1 plus a2 plus a3 power n is f of 1, and that will become the sum of all the coefficients. When we do some problems, this will be obvious. So just hold on for a bit. We will do some problems in the next video and you will understand what I'm talking about here. There is also binomial theorem for rational index. For rational number powers, rational index. So far we had written binomial theorem for n being an integer. If n is not a positive integer, and the modulus of x is less than 1, in that case, 1 plus x power n, we will not be able to write it as nc0, nc1, because nc0, nc1 are defined only for n being an integer. In that case, the binomial theorem looks like this: 1 plus nx, n into n minus 1 by 2, 1 into 2, x square plus n into n minus 1, n minus 2 by 1 into 2 into 3, x cube, and so on. And for example, the rth term here is n into n minus 1, n minus 2 till n minus r plus 1 by 1 into 2 into 3 till r, x bar r. And this series has infinite terms. There are infinite terms in this series, and this is the expansion. So here, n could be a rational, n could be negative integer, it could be anything. And this formula will always work. So it is basically writing the combinatorial coefficients, but writing them in terms of fractions, right? So nothing major has been done. We cannot write NC1, NC2 anymore. So we are writing it like this. And this series has infinite terms. The conditions have to be that n is not a positive integer and mod of x is less than 1. Mod of x less than 1 is a condition that the series is convergent. If mod of x is greater than 1, the series diverges to infinite, right? Notice that the binomial theorem had finite number of terms, and this for negative or non-integer rational index, the binomial series has infinite terms. And we will see the applications of this in problems. So in the next video, I'll be discussing a lot of problems on binomial theorem just so that you can revise the topic really well before your exams. So hold on for that video and I'll see you next time.